can do when you become a bit bigger one, then you will get some profit. But inside the class, if you do side talking business, it's not so good. No, side talking business is also very good. That is just talking with the person who is nearby and sharing our ideas, this and that. It can be done. But for study time, it's not so good. No, hey, resistance, this and that. I think what is left? Whole chapter completed? Not completed. Okay, today in morning time, we remembered and we saluted our one guru, George Simon Ogham. To whom? George Simon Ogham. George Simon Ogham, he gave one law. Which law was given by him? Ohm's law. What does Ohm's law state? The current flowing through a conductor is directly proportional to the potential difference across its two ends at a constant physical condition. It's very simple. What does Ohm's law state? The electric current passing through a conductor is directly proportional to the potential difference across its two ends at a constant physical condition. This thing must be kept in mind. Understood? And from this we have got one formula. What is that? V equals to Ri or V equals to IR. What is V? Potential difference. What is R? Resistance. What is I? Electric current. And numerical problem we have done. And children, what it was done? So here you can see here. This is the graph that shows voltage current graph. When voltage increases, current also increases. Then we can get straight line. Straight line. Right? Combination of resistors. Resistor means load. Load means those devices which convert electrical energy into other forms of energy, like that LED bulb or this electric fan or electric pressure cooker. Electric pressure cooker is also there. Here, electric kettle, electric hair dryer. Yes or no? And electric iron, vacuum cleaner. Vacuum cleaner converts electrical energy into mechanical energy. Yes or no? Why are you keeping that pen in your mouth? Attention. Sit correctly. Close your mouth. Open your brain. What are you writing, boy? Do one walk at a time. I have said you Parth and Bimali. Make backbone straight. There is one saying in Nepali. Java bhayo rati ani budi tati. Parson's situation like this. Look at his tie. Where's your tie? No. No was. No was. What is he saying? No was. And what about your tie, Master Anmol? Either wear correctly or keep inside. Okay. Now, today's presentators are going to explain about this combination of resistors, connection of resistors. How are they connected? Either in series, parallel, and total resistance, and some numerical problems also they may be discussing. Okay, so let's welcome on the stage the presentators. Who are the presentators? From Mendeleev, right? Edison, Smarika, Bhujel, and Krijal, Khadka. Please find out.
Sir, wait.
What are you Get the guy. Our hands and good.
Like this.
Whatever. What is
Smarika. Smarika. No animation. Okay, no animation. Just like evening.
Namaskar and a warm good evening to our science teacher and my fellow classmates. My name is Smarika Bhujel and I'm the reader, and here is Krijal and C is the explainer. We're from group Thomas Alva Edison, discussing about the lesson electricity. Now, without further ado, I'll get started. Heating effect on electric current. Some of
With
such
that
devices.
types of resistors, not resistors. You brought only to that name finish. Or continue.
Continue. Some of such devices like iron, kettle, roasters, toasters, geyser, oven, and different types of heaters convert electrical energy into heat energy. The devices which can change electrical energy into heat energy have the heating elements of a nichrome, an alloy of nickel 60%, and chromium 40%. Nitrogen has more resistance and a high melting point.
Nichrome. In the nichrome?
Nitrogen.
Not nitrogen, nichrome. Okay.
Nichrome has more resistance and a high melting point, about 1400 degrees Celsius. It does not oxidize over ever at a high temperature. Uses of heating effects of electric current. Number one, we use a number of such devices in our houses for different purposes. Two, heating effect of electric current is also used to dry things like our hair. Three, the effect is used in filament lamps to emit light. 4. Heating effect is used in protection of the electric circuit by means of fuses. 5. Heating effect of electric current is used in therm- thermocouples that work as an automatic switch in many such devices. Electrical power. Electricity can be used for doing different activities such as running electric motor, charging batteries, mobiles, cabs, generating heat, etc. The rate of conversion of a electrical energy, rate of a doing work, is the rate at which electrical energy is being supplied to an electric device. This is the
Formula to calculate
formula
power.
to calculate. This I will explain. These are some numericals and
Okay.
So, see, I've already read about these slides. Now I'm going to explain it. Heating effect on electric current. Some such devices like iron, kettle, roaster, toaster, geyser, oven, and different types of heaters convert electrical energy into heat energy. So these devices like iron, kettle, these toasters, and geyser, oven, we are very friendly to familiar to it. So these such devices changes electrical energy into heat energy. That is, when it is provided electricity, it changes its electric energy into heat energy. And the device which can change electrical energy into heat energy have the heating element of an nichrome and alloy of nickel. And 60% of nickel and chromium is 40%. And nichrome has more resistance and high melting point, about 1400 degrees centigrade. It does not oxidize ever at high temperature, even at high temperature. So next is uses of heating effect of electric current, and some heating effect of electric current are, we use number of such devices in our house for different purposes. So pressure rice cooker, or the hair dryers or heaters we use in our daily life in our home. Heating effect of electric current is also used to dry things like our hair. So drying hair dryer, we find it. It is also one of example of this. The effect is used in filament lamps to emit light, and this electric current effect of electric current can be used in filament of lights to glow it. And heating effect is used in the protection of electric circuit by means of fuses. Means of fuses means fuses also consist of some heating electric current, which helps in protection of electric circuit. Heating effect of electric current is used in thermocouples that work as an automatic switch in many devices. We have seen many automatic switches in devices. In those kind of devices also, electric current effects are used. So next is electrical power. Electricity can be used for doing different activities such as running electric motor, charging batteries, mobiles, taps generating heat, etc. So we know that electricity also can be used in charging our mobile phones, tabs, and many kind of batteries, and also generating heat, as we discussed earlier. The rate of conversion of electric energy, that is rate of doing work, is the rate at which electrical energy is being supplied. This is the rate in which electric energy is being supplied to an electric device. So next we have a conversion here. We have a formula for calculation, and P is equals to conversion of energy, that is E upon time T. In electricity, power is calculated. P means power is calculated by product of voltage along the two ends of the circuit and electric current, that is I flowing in it. So P will be equal with V multiply V times I. That is equation third. And next is, by applying Ohm's law we can get P equals to V multiplied I, that will be equal with I squared R. By placing the value of I from Ohm's law, we that is I equal to V by R. Also P is equals to V times I, that is equal with V squared by R. By placing the value of V from Ohm's law, that is V equals to R times I. In fact, the product of V and I gives rate of doing work by an electrical device. Also, the product of V and I, that is voltage and electric current, gives us rate of doing and work of an electric device. So voltage will be, according to the definition of potential difference, we can get that V is always equal with work done upon electric charge. According to the definition of electric current, I is equal with electric charge upon time. By substituting those values of V and I from equations I third and fourth in equation second, we get P is equal with work done upon electric charge into electric charge upon time, that is equal with work done upon W, that is work done W upon time T. So next we have here a numerical problem. So we have given here voltage 220 V, electric current 5 ampere, power we should find out, and electric resistance we should find out. So first we have to use the formula of power, that is V into I. So according to the definition of power, we can go through V into I. V means voltage, we have 220, and I means electric current, that is 5, and 220 multiplied by 5, it will be 1000. So and power here is W, it means watt, that is watt is as a unit of power. Again, according to Ohm's law, resistance is equal with voltage upon I, that is electric current. That means here we are multiplying, here we are dividing. It can be easier for us to remember the formula also. And 220 divided by 5, it will be 44 ohm. This symbol is omega, but we generally call it ohm. Next is next numerical in number 2, we can get solution. We have given power 750 watt, voltage we have 220 V, same as before, and electric resistance we should find out. So first we are going to find I. From the definition of power, we can substitute those values according to question and find out I, that is electric current, and its unit is ampere. So we get your 3.4 ampere. So again, according to the Ohm's law, we can also use that resistance. Once we get the electric current value, we can find easily resistance. So we are just using here formula same as power equals to V times I, just substituting those value and getting I. And after that, according to Ohm's law, we can use R is equals to with voltage upon electric current, that is, now I will go there and R will come this side, so it becomes dividing. It divides 3.4 divides to 20, and that will be equal with 64.7 ohm. And this will be the resistance of the immersion heater having the power of 750 watt. So thank you. By saying this much, I like to conclude.
Thank you very much. So, children, here one thing is lacking. So, what you have done, that's very good. But what is lacking is some diagrams of this. What to say? Series and parallel your registers, and the way to calculate their value. Right? That is lacking. So, master showed only the diagrams, but there should be this thing. So, where is it? Load. Uh, I in morning time also we discuss about uh, two type of combination of load. Load can be combined in two ways. What are they? Series combination and parallel combination. I know the difference. How they are connected? In series, they lie in the same side. Yeah, or in same wire they are connected. But in parallel, they are connected in different wires. Yes or no? So, uh, here we have to remember disadvantage of using those registers in series combination. Here are two disadvantages. What is that? Point number one, if one electrical appliance is connected in series does not function, rest of others also they do not function. I mean, if one bulb does not glow, others also they do not glow. That is demerit. Please pay attention. Next one is at the same voltage, electrical appliances with a different power cannot be run using the same switch. So here, if it has a power 20 watt, another 50 watt, here is 60 watt, they do not run. For that, they must have equal power 10, 10, 10, 15, 15, 15, 20, 20, 20. Okay, this is the disadvantage. And here is one formula. So, in case of series combination, total resistance Re we can write equal to R1 plus R2 plus R3 plus that is Rn. Means total resistance is the sum of resistance of all resistors. This formula must be remembered. What is the formula? Rn Re means total resistance equals to resistance of first one, second one, third one, fourth one. For example, if the resistors are connected like this, if R1 is 5 omega, R2 is 7 omega, R3 is 8 omega, R4 is 3 omega, then what is the total resistance? What is the formula? R1 plus R2 plus R3 plus R4. R1 is how much? 5 plus 7 plus 8 plus 3. How much does it come? How much does it come? 5 plus 7 plus 8 plus 3. Sorry? 23. 23. That means if the loads are connected in series, the total resistance increases. Okay, total resistance increases. But if they are connected in parallel, this is the example of parallel, or diagrammatically we can draw like this also. This is the symbol of load, resistor. So in total resistance in parallel combination, what is the formula? 1 by R equals to 1 by R1, 1 by R2, 1 by R3. That means total resistance increases or decreases? Decreases in parallel. That's why in our domestic circuit, all the devices are connected in parallel connection. All the devices are connected in parallel connection. So, two numerical problems they are given here. You have to remember about this heating effect, and next one electric power consumption. We will be discussing next day. Will that be okay? Because we don't have more time. I think small portion of note is left. You can prepare now. All right, come on.